Today we're going to take a look at finding the area of a sector and the length of an arc. So before we get started, remember how to find the area for a circle. The area formula for a circle is pi times the radius squared. So we just really need to know the radius of our circle. All right, let's jump in. The area of a sector is simply a fraction of the circle that contains the sector. Simply put, a sector of a circle is a region bound by two radii and their intercepted arc. Now, if we take a look over here at our picture, this is what a sector looks like. It's essentially like a slice of pizza. Here are our two radii, CA and CB, and the intercepted arc is AB. This area between those two radii and that intercepted arc is called the sector of the circle. We can simply find the area of the sector if I know the central angle. The central angle, remember, is the angle between these two radii. It's also that arc measure AB. So here's how we're going to calculate the area of a circle, the area of a sector. We start off with the area of the circle, pi r squared, and then we're going to multiply it by the percentage of the circle that contains that sector. And the way we find that percentage is it's the central angle divided by 360 degrees. Let's take a look at a few examples. In this first example, it says to find the area of the sector to the nearest tenth. Remember, we're going to take a look at our sector and see what information they gave us. The central angle JGH is 131 degrees, and I see that the radius of this circle is 12. Those are the two pieces of information that I need to know in order to find the area of this sector. I'm going to start off by finding the area of the complete circle. That's pi times the radius squared, or 144 pi. Next, I'm going to multiply that by the percent of the circle that this sector makes up. And the way I find that is I take the central angle, 131 degrees, and divide it by the full 360 degrees of a circle. Next, I'm going to multiply this all together because I want to find my answer to the nearest tenth. So 144 pi, I can insert that right into my calculator, times, and then I'm open up a set of parentheses and do 131 divided by 360. Close that parentheses, and I'll get the area of this sector to equal 164.6, and this is in meters squared. On our next example, I have a radius of 6 inches and an arc length of 40 degrees. Well, remember, this intercepted arc is the same as that central angle. So this angle in here is 40 degrees. I'm going to start by taking the area of my circle, pi times 6 squared, and then I'm going to multiply it by 40 divided by 360. You complete the rest of that problem and let me know what you get. Next, we're going to talk about finding the segment of a circle. A segment of a circle is the region bound by an arc and its chord. So if you take a look here at our picture, here's our circle, and this arc right here and the chord that goes between the endpoints of the chord and the arc form this segment. So this shaded area here is called our segment. Now there's an easy way to kind of go about finding that. The segment of a circle is simply equal to the area of the sector minus the area of the triangle that goes between the radii and the chord formed between the endpoints of that sector, or the endpoints of that chord. So remember how to find the area of a triangle. So we have the area of a triangle is simply base times height divided by 2. So here's an example. It's asked us to find the area of this segment. Remember, the segment here goes from the endpoints of the chord, Ln, and is bound by that arc Ln. So I want to find that area in there. So I know that I need to find the area of this sector and subtract the area of that triangle. Well, if I take a look at my drawing, the radius here is 6. And the central angle here is 90 degrees. That's going to help me in finding both of these areas, because I know that the area of a triangle is simply base times height, in which both of those bases and heights are now going to be 6, the length of my radius. So I'll start with the area of my triangle. This is base times height. divided by 2. Now let's talk about finding the area of this whole sector. That's everything in between the two radii and the arc. Remember, that started off by finding the area of the circle, pi r squared, and multiplying it by the percent of the circle that that sector makes up, which in this case is found by taking the central angle, 90 degrees, and dividing it by 360. So this becomes 36 pi times 1/4 minus 6 times 6 is 36 divided by 2 is 18. When we do all this, we can enter that straight into our calculator. We are going to come up with the area of that segment to equal 10.3 inches squared. In our next example, we're going to take a look at finding the arc length. Now, remember that the circumference of a circle is found by taking pi and multiplying it by the diameter, or simply taking 2, multiplying it by the radius, and then multiplying it by pi. Well, arc length is a fraction of the circumference of a circle. Just like a sector was a fraction of the area of a circle, arc length is a fraction of the circumference of the circle. Therefore, the arc length is simply measured, I got to check my notes here, measured along in linear units. Now, skip that part. Go back and skip that part. Okay, arc length, therefore, is going to be the distance along the border of a circle from one endpoint of the arc to the other. And we can find that simply following this formula. We are going to take the circumference of our circle, which is pi times the diameter, and then multiply it by the percent of the circle that arc length makes up. And the way we find that is by taking that arc length in degrees and dividing it by 360, which is the complete circle, or the complete degrees of a circle. Another way of writing that is simply saying 2 pi times the radius, which is another way of saying our circumference, multiplied by m, the central angle, divided by 360 degrees. So let's see how this will work in an example. It says find the length in centimeters of the arc FG. So here's our arc FG. It comes along the circle here. I want to find out what percent or what portion or what fraction of the circumference this arc is. I see that the arc measures 134 degrees, and I see that the radius of this circle is 8. So if my radius is 8, I know my diameter is 16. So I'm going to say it's 16 pi times the 134 degrees divided by 360. I can enter that all into my calculator, and when I do that, I should get an arc length equal to 18.7